Okay, so this one here, well, if I multiply it out, yeah, I get square root plus x. No, that doesn't really work out. But if I leave it in this factored form, I can see that if I choose this as my inside function, really I don't have much choice, but if I choose that whole thing as my inside function, that can account for this outside piece here. And I'm going to include the 1 in there because it's a lot easier to deal with that extra constant in the derivative because it just disappears than trying to keep track of it in an integral. So I'm going to let my u equal 1 plus square root x. And then my derivative is going to generate that 1 over 2 root x. So there's my du, 1 over 2 root x. And I'll move the dx over. Yeah, there it is. Okay, it shows up again. So now again I can apply my substitution. Okay, this is the same as the integral of 1 over u, and then I can eliminate the du, sorry, the dx over 2 root x with just the du. That du replaces all of that because they are equivalent. And then now this becomes a fairly easy integral, log of u plus c. Okay, knowing that u, we can replace that u with the original function. So we end up with log of 1 plus root x plus c. Okay, and again I could check this by differentiating this. Okay, this is a good way to check our integrals. So doing a bit more the same, we're just doing examples here. Again, we want to find an inside function. Okay, we're going to look inside the denominator here, so that 1 over x function, and its derivative will generate the outside here. And again, we could, leave that plus 3, but it's easier to keep that plus 3. I was doing this in green, wasn't I? Letting my u be green. So I'm going to let u be equal to 3 plus e to the x. Okay, so it makes things algebraically a little bit cleaner if we can put that constant in the u. That way, when we calculate the du, that plus 3 is kind of out of the way for now. So we end up with e to the x, move the dx over. There's my e to the x dx, and I have my u right here. The u is in the denominator, so it's a rational function, a 1 over x function. So I'm going to get 1 over my u value. Okay, and then I'm going to replace that e to the x dx with a du function. And then again, we are dealing with a log function. When we anti-differentiate this, log absolute value of u plus c. There's my u, and I can express that back with x's by just substituting that with my 3 plus e to the x plus c. Now this absolute value is not necessary as e to the x is always positive.